Okay, I think we get started there. You're telling me we're starting. Welcome you everyone to this talk from Abingdon to Silicon Valley. It's a great pleasure to have Neil Carson speaking to us today. There's a number of groups joining online. There's OAs, there's members of partnership schools, there's pupils who are away from here for COVID-related reasons. Anyone like that who's away, just send the questions through on the Q&A and I'll put them on. In the room, as you can see, there's a number of boys who are present in school, and there's also the headmaster, Mr. Mike Windsor. So I'd ask him to say a few words.
Yeah, hello everyone. Before we start, I just wanted to say a particular welcome to Neil and a personal thank you. This talk was planned to be part of the events that we are running to mark the opening of Farringdon Lodge as our newest building on the site. But sadly, COVID-19, as with so many things, intervened and prevented Neil traveling to the UK. So I'm really sorry that you're not able to be with us today, Neil. We're hoping to show you around the new building and to thank you too for the support that you've shown to the school over the years. And I know it's been a while since you've been back at school, but it's fantastic that you've made the time for us today to tell us about your journey from Abingdon to Silicon Valley. And I'm very intrigued by the subtitle as well, and wondering whether we have any hackers sitting in the room at the moment. I suppose, you know, we look at the silver linings, don't we, in these instances, and it is great that we are joined by some OAs and people from partner schools, and that we know this is being broadcast around the world, and that some of our pupils are joining us from Hong Kong and China, where they're working remotely at the moment. But there is good news emerging. I think we all heard the news from Pfizer about vaccine and got quite excited about what next year might hold. So I hope, Neil, it won't be too long until we can welcome you back.
Fingers crossed.
But in the meantime, thanks so much. And we look forward to hearing your talk. And I'll hand back to Peter for the introduction.
Thanks very much, Mike. Yes, Neil Carson, our speaker today, he left Abingdon in 1994. He went to Cranfield University and did a degree in software engineering. Started a company in London, and I know he's worked in Hong Kong and California. Spent many years working with new ideas and building companies. He's now CEO and joint founder of Yellowbrick Data, a data warehousing startup. And it's been very successful so far, but startups always have challenges. So data warehousing, in 5 years' time, we're expecting 10 to the 20 bytes of data per day worldwide. What on earth happens to that data? And data warehousing is part of the solution to that. So without further ado, it's my great pleasure to ask Neil Carson to speak to us. Abingdon to Silicon Valley, story of a hacker turned entrepreneur.
Well, thank you very much, Peter. And yeah, it's really a shame to not be in the UK in person right now, but given the 2-week quarantine and heaven knows what would happen afterwards, I decided to stay put for a little while, but hope to come out in the new year. And it's been, the last time I went to school was when I was 18, literally. So it's been quite some time. I'm sure some things have changed a lot. So I didn't want to make this story too boring and spend the whole time talking about me. So I'll just talk about me a little bit and, you know, add some photos and things to give some sort of context. So I think there's probably about 2 pictures of me in this thing. So this is the first one. This was me in 1982 with my first computer. It was something called a Commodore VIC-20. It loaded software off cassette tapes. Looks incredibly archaic. I loved playing video games and wanting to know how games were made, and always had this natural curiosity to want to learn how things worked. So given that, I sort of read a book, and there was a book about programming the computer in BASIC that came with the computer, and I started to learn to write computer programs. And I found that I just loved writing computer programs, and I wanted to do nothing but spend all of my time on my computer, which meant, you know, not doing studying, not doing sports, not really doing anything except spending time working on the computer. So I got admitted to Abingdon. There was some support. My family wasn't a wealthy family, so the place was assisted, but I kicked off anyway in the lower school at Abingdon, and did a little project in the lower school to publish a magazine. I still have copies of the, the thing at home here for some reason. But, you know, really the reason for doing this was to learn things on the computer. And desktop publishing was becoming a thing back then. And back at Abingdon, in the back of the physics lab, the physics teacher at the time had a number of computers, and I wanted to do all the projects I possibly could to spend time on there and learn as much as I could. So I would spend my evenings after school on the computer and after hours, and learning really as much as I could, doing things and publishing things. So as time went by, I went through and used an awful lot of different computers. The one at the top left is the Commodore VIC-20. The one at the top was the first one I bought, an Acorn Electron. That was the second one, and I had to save money for ages to buy that thing. And over time, sort of using, you know, wanting to buy more computers turned out to be really problematic because they were pretty expensive. So some of these we used at school. The top right one here, this Mac Plus, was the first computer used for desktop publishing. And one day in the back of the physics lab, this thing on the bottom left appeared, which was this majestic machine back then called an Acorn Archimedes. It had an 8 megahertz 32-bit processor, which was a really big deal back then, running something called sort of a RISC instruction set, which was a sort of a new scheme of thought for building computer processors out of Berkeley. Traditional processors would use multiple ticks of the clock to run each instruction. With RISC, they made the instruction set really small, so it did a small number of things really quickly, rather than a lot of things very, very slowly. So that was the first RISC computer. Back then, it was the processor used in it was called ARM, which stood for the Acorn RISC machine. And it went on to produce a couple more computers, which were the ones on the bottom right here. This thing called a RISC PC here, and on the bottom right, another one of those that both of which I sort of saved money to buy. But the Acorn RISC machine, at some point, Acorn Computers wasn't doing very well, and they spun off the company that made the chips into something called ARM and relabeled it Advanced RISC Machines instead. ARM is now the most popular processor on the planet. The design came out of Cambridge and is now used in, you know, every smartphone, every vehicle, most microwaves, most appliances at home, embedded systems, cameras, integrated in a bunch of GPUs. ARM is literally absolutely everywhere. That technology came out of Cambridge, came out of Acorn originally, and I was just super, super fortunate at school to have exposure to this ARM computer here and learn things about programming the ARM at the end of the day. So it was clear that I had to make more money to buy more computers. So as I kept going on this journey, when I was in sixth form, I got my first ever magazine article published about a program that I wrote, which was really, really cool. That was something called shareware, where you just gave the software away for free, but if people liked it, they would send you money in the mail. And I think I charged 5 quid or 10 quid for the thing. And all of a sudden, envelopes started showing up with money in, because it turned out people really liked it. And I thought that, well, maybe we're onto something building software here. So as I bought more computers, spent more time on the computers, sort of quite honestly scraped my way through school and graduated, and got into the Royal Military College of Science, part of Cranfield University. It actually doesn't exist anymore. It turned out there was a business opportunity because this ARM technology was going everywhere. These were all computers that were being built around the world with the ARM technology. So we sort of went ahead and, you know, we've got now, this was one of the first computers I collaborated on building, an evaluation board. These were point of sale terminals, tape controllers, the original iPhone, of course, based on ARM. BMWs have ARMs in them, and, you know, all of this stuff. So the world was going ARM. And even today you see, you know, Apple Silicon being announced by Tim Cook, which is based on the ARM architecture, right? So there was this huge business opportunity that was, nobody really knew quite how big it was going to be, but to do something with the ARM. So sort of set off, decided, hey, we can build a business around this. So while I was at university, my friend Mark and I, we sort of collaborated to build an operating system for the ARM, because the only thing that would really run on it was this Acorn stuff that was dying out. And everybody really wanted an OS like Linux or Unix or something like that. So we started doing the first Unix project for the ARM. I think we still actually have code running in the iPhone as a result of this project back when I was just graduating school. That code is still out there and running in probably most iPhones today, which is pretty crazy. But we started building an OS for the ARM. So we went off to some customers in Hong Kong at Hong Kong Polytechnic University. We built software for tape arrays. We built software for storage devices from Quantum and Maxtor. Oracle, the database company, wanted to do stuff with the ARM. And so we created this company that we called Causality, which turned out to be a really unfortunate choice of name because everybody read it as Casualty. You know, it teaches you that naming is an important thing, although perhaps we haven't learned that lesson yet. But back then we saw all of this business opportunity, so we said, let's create a business. So we started putting a business together. And this was another newspaper article of Mark and I, two geeks with a bunch of pigeons, basically, you know, interviewing about the company that we'd started to take this software technology for the ARM and start commercializing this all around the world. And so we got on with this, but it was really hard to do this back in England. Back then, you know, accessing the internet used modems still. In the US, broadband was really popular. It was becoming really popular in Asia. In England, you had dual ISDN lines that were crazy expensive. We went to Barclays and said, hey, we've got all these contracts from Oracle and Storage Tech, and we want to open an office. Can you loan us some money? And I think we wanted a loan for £300 to pay the deposit on the first office. And they said, well, you know, no, sorry, you don't have any business history with us, so we can't loan you any money. Well, isn't that the whole point of a loan for starting a company, that you don't have the history? But in any case, that was really, really tough to get started. We got our company going anyway. We grew to about 4 or 5 people in England doing consulting work around this ARM processor. And, you know, the consulting work took us to Hong Kong, which was really cool, where we worked on ship simulators for teaching drivers how to park their boats. A bunch of this I did in my last years at university as well to help pay for life at university and keep things going. But I sort of overlapped the work and graduation. And, you know, our biggest customer turned out to be this company called Oracle. Oracle, which is now, I gather, the owner of TikTok, or about to be the owner of TikTok, started as a big database company, actually the biggest in the world at the time. This is their office over here in Silicon Valley. And at some point after doing this for a few years in the UK, Oracle said, hey, why don't some of you guys come over? We'll move you over here, we'll help relocate you, and you can go lead a team doing operating systems and software for the ARM in Silicon Valley. So we moved over in 1998, and Silicon Valley has been mostly home ever since. So it's a pretty crazy journey, but I thought I would tell you guys just a little bit about life in Silicon Valley and what goes on here. First of all, a high-level overview as to the geography of the place. This is a pretty busy map. You can see Oracle halfway up the peninsula here, just by the San Francisco Bay. The valley has San Francisco in the north. This big sprawling mass down here at the bottom is San Jose. And here you've got all sorts of businesses that have started. Facebook was born here, Intel was born here, HP born here, Apple is still here with their UFO-like campus, Intel that produces the CPUs, Salesforce.com up in San Francisco, the first software as a service company that was well known. Tons and tons and tons of technology has been created here over time. The history of Silicon Valley was such that, you know, people really view 1938 as being the first year where the valley started. This garage is just down the street from where I live in Palo Alto. It's called the HP garage. It's actually privately owned, but it's listed in some way now. But this was where this company, Hewlett-Packard, started. The guys made the first working audio oscillator that was given to Disney in, I think, 1938. HP went on to produce the first portable calculators and a whole bunch of other things. So this stands as a monument to innovation. But the amount of stuff that has come out of Silicon Valley since 1938 is absolutely crazy. Here's some of the stuff that's been made here. The silicon transistor was invented here, the first microprocessor. Xerox PARC, the Palo Alto Research Center of Xerox, was where Ethernet came from. Copiers, of course, but the first graphical user interfaces, the Mac that made the first sort of Windows and mouse-based UI, got its start by looking at the research at Xerox PARC. The internet was really created here. Homebrew computers, which made home computers, and Apple came out of. The whole venture capital industry for investing in startups. The mouse, the GUI, the first web browsers, Mosaic and Netscape, which begat Internet Explorer and became, you know, everyone started producing web browsers back then. Search engines, Google, software as a service, the first really usable electric car, the Tesla, social networks, although Facebook didn't actually start here, it commercialized and grew here. Rideshare, the demand economy like Uber and Lyft. So much of the technology that we all know and use today came out of Silicon Valley. And so it's a really, really special place. And one has to ask the question as to, well, what are the secret ingredients and sort of why is it and how is it that that happened? So there's a chap who's sort of a fairly famous historian of Silicon Valley around here, a guy called Mort Grosser, who one sort of tends to bump into at one of the local cigar bars fairly often. And so if you ask Mort about what's special about Silicon Valley, you've got sort of the normal list of things plus one extra bullet here. You've got really good universities and institutions, Stanford and Berkeley being two of the most well-known. You know, NASA has a really big campus here. Before then, there were tons of you know, defense companies working here, Lockheed Martin and others, that all sort of built intellectual capital at the end of the day. You've got money and people who like to take risks in investing in businesses. Whereas in England, it was really hard to get sort of a £300 loan. You know, starting our first business over here, some people actually loaned us millions of dollars to have a go at our idea, which was just sort of a really different order of magnitude. But it's sort of the biggest market in the world for investing in tech, with 45 to $60 billion a year invested in startups, most of which fail and most of which don't do well, but the ones that succeed make it worth it. You have an immigration-friendly culture as well here. A whole bunch of educated entrepreneurs, like Palo Alto is one of the most educated places in the world. 8 out of 10 people here have a degree, 50% of professional or graduate degrees. You've got really, really diverse culture because tons of people have moved here as a result. The population around me is 30% Asian, 25% Hispanic, and 40% white. But strangely in America, very, very few African Americans. And that's sort of one of the big social problems in America at the end of the day, that we try hard to hire and develop more. But there exists a culture here where people of that race find it very, very hard to be successful. It's really sad. But the most important thing per Mort is a culture of meritocracy, which means that people are more even. In England, the work culture back when I was in the UK was all around strict management hierarchies, the boss showing up on time. Here, things are around taking risks, getting things done, most importantly, listening to bright ideas, accepting bright ideas, and giving young people a chance to be heard, a voice, the ability to explore their ideas and take risks. When I first moved here, the first company I worked at was called Network Computer. It was part of Oracle. And we came in and looked at the technology stack and we just thought, God, this technology is an absolute disaster. It's sort of barely hanging together. It's never going to work properly, and it's probably never going to ship. So my friend from England, Mark, and I, we sort of came to a bunch of folks and made a case to the management chain. Hey, we who know nothing and just moved here want to rewrite and blow up this entire thing with a torpedo and rebuild this entire software stack. And they said, all right, off you go then. Have a go and see if you can make it work. And it worked. And so the next job did the same thing. And the next job after that did the same thing. And at some point sort of decided that, hey, you know, maybe one should try and do this for oneself and start a business instead of fixing other people's stuff. But along the way, learned a few personal lessons as to how to succeed here. One, if you ever go work at a startup in Silicon Valley or in the UK, understand compensation. It's not just about the pay here. You've got things called stock options and RSUs. So everyone here is encouraged to have shares and own shares in the companies they work at, so that if the companies are successful, you'll make money by dint of the company successful. It sort of puts everyone in the same boat at the end of the day. So there's a lot of complicated instruments there that are worth understanding what they mean when you guys get there. Number two, understand the work culture here. America's a very direct culture. If you want something, ask for it. If you want to get something, ask for it. And leverage the meritocracy to take risks, drive things, even if it's in someone else's company and not your own company. Third, most importantly, work hard and just get stuff done. If you want to be a successful technologist here, getting things done is the most important thing. it's really important to ship products to people, get products in people's hands, get stuff out the door, because that's what you get recognized for. When I first moved here to make a name for myself and for the folks, I worked 13 hours a day, 6 days a week. It was crazy long work hours, but I loved doing every minute of it. And it was always my passion from back from 1982 when I was 6 or 7 years old. So I was able to leverage my passion to do really, really well. Given that time is the most precious resource all of you have, if you want to succeed really well in technology, don't spend your entire career working at one company. Think of your time like you might invest money in the stock market. Work at some different companies, gain different experiences, try big companies. In big companies, you'll learn how large structured things operate. In small companies, you'll actually be able to get far more exposure to the business, not just the technology, and be able to learn and grow your business acumen. Spend time with customers, see how things are built, see how things fail as well as how they succeed. Because really the culture here is that failing to do something, as long as you learn from it and move on, is actually a good thing. It's very common here for entrepreneurs who failed once to still get funded to go and have a second go or third go if people really think they did their best and it was other circumstances, or they've been smart and learned from what they've done. And finally, once you've done all of that, if you're really into technology and doing things, join a startup as part of the founding team or go found something yourself. I've done it twice in my life now. I'm not a serial entrepreneur, and there are people who've been far more impressive serial entrepreneurs than I have been and probably will be. But just for me, as basically an extreme introvert, a programmer and hacker from Abingdon, what I've been able to accomplish myself here and the life experiences I never for a moment thought that I would have been able to do as a result of doing all of these different things. So I thought I would talk a little bit about just if you want to do a startup, just to sort of plant some seeds a little later. The first thing is come up with a really good idea and brainstorm. Spend time with your friends, the colleagues, the things you've learned from work at the end of the day. The next thing is to build a business plan for what you're doing. How big is, this is one of these sort of geeky acronyms here, the TAM, the total addressable market for the stuff that you want to build, i.e. if you've got an idea for a product, how much money is spent on that product every single year? Investors will look at that. It's got to be big enough that you can grow a business that looks like it will get to several $100 million a year over 7 to 10 years. So people want to invest in big ideas, not small little ideas. For your product, you've got to work out how to differentiate it. Try and build a minimum viable product, i.e. what's the bare minimum software that you can build in your technology to get something into the hands of people, to get feedback. Given it's probably feature constrained, how big is the serviceable market for that, the SAM, i.e. the first thing that you put out, how much money can you make from that? What patents can you file? What's the core special sauce that you've got in your product? How will you take it to market? Do you hire salespeople to sell it? Do you transact it online? Do you sell it through retail, through other channels? And how do you measure your success of selling the product? Who are the critical people you need to advise you? And who are the folks that you need to get it done, and can you hire them? It's really important to have good mentors as a first-time entrepreneur. I spent a lot of time finding and learning people I've worked from that were smarter than me and giving them some shares in my company so that they're incented to give me advice and help me with the journey of going from being a programmer to a CEO of a business. What's really useful when you do this is to have prospective customers who say they will buy your idea. If they say, yep, Joe, if you go build that thing, yeah, I'd buy that. And this is how much I'd pay for that. That is invaluable to an investor. And perhaps you have time to do a prototype or a demo. So that's all of the stuff that goes into a business plan for a startup. It's a lot of work. Then you have to work out how to raise money for your startup. Start with small angel investors, do a big venture capital round. There are trade-offs to both approaches. Work out how much money you need to get to beta and getting a product out there and get feedback. Don't be shy about how much it's going to take and be conservative in your estimates. Work out what you think your company's worth, how much money you need, and raising less money doesn't make your venture any more attractive because people want to have high odds of success in what you're doing at the end of the day. So these are all things to think about. And if any of you guys ever get through graduation and you decide, heck, I want to try a startup, or later on in life try a startup, feel free to reach out and I can give you whatever advice it is that I've learned doing this stuff. again, there are far smarter people than me, and I can connect you to some of those as well. So what does fundraising look like? I found this very, very hard as a first-time programmer turned entrepreneur. There's this road called Sand Hill Road in Silicon Valley where all the venture capitalists hang out. And you go from meeting after meeting after meeting. And one of the things that I have to learn is that every time people would say no, and they normally don't say no directly, they'll just sort of disappear because no one wants to burn a relationship. Whereas I wish, people would actually give the feedback. This is why we said no, and this is what you need to do better. But raising money was like getting kicked in the head time and time and time again. The first funding round for Yellowbrick Data was really difficult to get done. It took 6 to 12 months of being told no, of changing the recipe, changing our product and the market fit, and learning how to do this for the first time. And I learned really through the school of hard knocks of knowing what doesn't work. Almost came to the point of giving up until realized that actually there was a way to make traction, found a couple of friendly entrepreneurs who would actually give feedback and give useful, valuable feedback and tell us what we were doing wrong, at which point we made great progress. So venture capitalists will sometimes play games when you're raising money. Don't pass the name of other interested people to VCs, otherwise they'll try and collude to go together to limit your options and get a better deal in your company. Don't take too little money, and don't ever trust anyone that says, well, if they invest, then I'll give you money as well. Basically taking an option on your business. That's fake interest and just a fear of missing out. Often venture capitalists follow other investors at the end of the day. So the minute someone is in, they get you this thing called a term sheet, then others will follow if you need to raise more money. But getting the first one is the hardest thing. So these are some of the lessons I learned from doing fundraising for my startup anyway. So at Yellowbrick, we came up with an idea to build a new type of database to store vast amounts of data using the latest hardware and system innovations. It was a really big market, $15 to $25 billion a year. So as we looked at the market and the feature set we were building, we could show that we could build a business that would get to hundreds of millions of dollars per year. We built database software with hardware, which is a very out of fashion things to do these days. Always loved hardware, won the electronics prize back at school for building an infrared telephone, having designed some strange things, and ever since then loved hardware as well. So did both and have done both ever since. We did a direct sales model with quoted enterprise sales reps. We took a network of engineers from successful companies. Fusion.io was a company I worked at that I helped IPO. Never believed at school that I would be the opportunity to go onto Wall Street where it's going ding, ding, ding on the balcony and IPO a business. Just an amazing journey there. Took a great bunch of engineers from there. We had a lot of prospective customers and built a demo. So doing that, we were able to get Yellowbrick started and raise our Series A. I was asked to talk a little bit just about what a data warehouse is for the computer science students. So I put together a small technical diagram here. A number of you guys study database design in SQL, I gather. I actually didn't study that till university, so that's really, really cool. But a data warehouse is a type of database classically used for reporting and ad hoc exploration of business data. The schema is different. In a lot of the databases you'll learn things like third normal form for laying out data. Data warehouses use star schemas or snowflakes. I've got an example of a star schema on the right-hand side here. The idea is you have a big fact table. The fact table stores all the data that's happening in a business. So in this case, this is a data warehouse for like transactions in retail or something like that. So the idea is the only new data you need to load at the end of every day from your transaction systems is new lines in the fact table. And around there, you have what you call dimension tables, which are the little ones. So the transactions store perhaps the date when the transaction took place, how much it was, which customer, which store, which product, which promotion, and how much it sold for. These tables that contain all the details on what you call the dimensions, the customer, store, product, and promotion, are what you call dimension tables around the outside. I won't go into too much detail, but this type of schema layout makes it very, very quick and efficient for the database to be able to aggregate and analyze data by customer, by store, by product, or by promotion. So you could say, aggregate for me the total sums per month of transactions per store in a given promotion. And because of how the data is laid out, the special type of database can do this sort of operation very, very quickly. Data is loaded from transaction systems with a process called ETL, which stands for extract, transform, and load. People tend to use Spark for that, or traditional ETL tools for doing that. And the term is very, very broad now, because as he said, so many data warehouses now store so much data, and so much is ending up in them. We have data warehouses where the fact tables are literally trillions of rows. Like every big telco in the US, for example, a bunch of their call and data records end up in Yellowbrick data warehouses. So that means every time you use your phone to access data online, to move data, or every time you make a phone call on your mobile phone, all of those records will end up in a Yellowbrick data warehouse that will get used for revenue assurance, to make sure the phone bills are correct, to calculate the prices for when you go roaming to send the bills to other carriers, this sort of thing. And our technology is really diverse and out there. It's crazy. I mean, a lot of the big supermarket chains here, it turns out when the weather's really good and it's sunny at the weekends, they should stock more sausages. They arrived at that insight through Yellowbrick, and there are tons of other really fun use cases. The cool thing about data warehousing is it is where business and technology meet, because you do all this engineering and technology, but the data you use is all the stuff to make your business decisions. So it's a great way to learn about business. So we're a few years into this journey now. We've been at this about 7 years. We've got fabulous technology. We've got giant insurers, credit card companies, payment processors, telcos, the government, online transaction companies, all analyzing stuff with Yellowbrick. I mean, if you use Lloyds Bank in the UK, or you go buy things online from pretty much anyone other than Amazon, Yellowbrick's making sure that you are you and no one's ripping off your transactions. We've built a really good business, but we need to grow faster. We haven't grown fast enough this year. Our sales model has shown to not work very well in the event of coronavirus, so we have to do an overhaul there. A lot of our sales was done by personal relationships, which are far harder to build and cultivate now. So we have to move to much more of an online sales model. So that's forced me to grow and understand absolutely everything. I never once knew much about sales, how to manage sales, how to motivate sales reps, how to model pipelines and business development and measure it and improve it. I've had to learn all of that and grow beyond my technical and product foundation in order to keep evolving things in the company. So the other thing I've learned is that sort of the human impact of technology is a really big deal. We have to find a way to give back. And the coronavirus has just exaggerated that. When you see how it affects disproportionately the poorer people or the working class people, it's really sad. And we have to find ways to give back. So at Yellowbrick, I did that early on by giving a lot of stocks in my company to different charities around the world, so that if we're successful here, those charities can go and help both third world people as well as folks that are disadvantaged, and help people in education as well. So the hope here is that we'll IPO this thing in 2 to 3 years. It'll be the second IPO I've been able to do in New York, if we get there, which I'm hoping that we will do. And then I think I've had enough of that. I'll call that a success and move on. But that's what we're all moving towards here. So you really never stop learning in this game and in this world as an entrepreneur. So given that, I thought I'd just share some of my regrets from school. One, I didn't find very many things interesting at school other than computing. And I don't really know why that was. I've realized that there was a lot of missed opportunity, especially in the other half at school. The things that one could have learned and discovered at Abingdon were so broad that I just wish I could go back and do more of that right now. I should have balanced my life much more. I've become an avid woodworker, an avid builder, and the school would have been a great time to pursue those passions I never did. I failed terribly at sports. I was always the last to get chosen for a team, and part of it was I never ever pushed myself to want to do well. And I look back now and ask myself why. That was also an wasted opportunity, because one of the things that I've learned the most going through this journey in work and life is to find myself to challenge things, to do things that I think that I can't do. And when you do that and you push through the boundaries that we set for ourselves, I find that I can almost always do them at the end of the day. And I should have done more of that at school as well. But, those are some of my regrets. And, the passing thoughts were just to thank everyone in my school and my teachers, who are many of which no longer with us, for just letting me explore my passion and grow. Some of who turned a blind eye to things that I should have been doing and didn't. But overall, because of their kindness, generosity, and willingness to do that, I was able to grow and get to a place in life that I never possibly imagined that I could have done. So given that, just a quick summary, as you guys go out into the world and pursue careers in technology, let's try and make it a force for good, find a way to give back more in terms of what we're doing, even if the products we build don't necessarily help the poor people or the disadvantaged folks. We can do it indirectly by finding ways to help them. And secondly, I'm still have learned an absolute ton, but I'm still learning and still growing. And the most important thing I found is to, throughout this whole thing, be absolutely humble and just never assume I'm really an expert in anything or know better than anybody. And as I've seen the people that haven't done well here, a lot of it has been because their egos have got in the way, or because they've just decided that they're masters of their own trade and have stopped learning. So we've all just got to keep learning and growing. So I think that was about that. I'll turn that off, but if there are any questions, and do a quick time check here, we're about right, 35 minutes, perfect. If there are any questions that anyone wanted to ask, I'd be more than happy to take some questions from folks.
Great. Well, that was fantastic, Neil. Any guys here? Come forward. Will? Sorry, just come over here.
Oh, we got some questions that have been typed in actually, so I can grab a couple of those first. Okay. How did I actually get to Silicon Valley as a UK resident? Should I try to join a big company? So yeah, so I got to Silicon Valley for working for Oracle. They have a visa type in the US called an H-1B visa that allows a company to sponsor foreign workers. And so I was able to get an H-1B visa sponsored by Oracle. I didn't actually work for Oracle in the UK, but as a result of the work that we'd done doing open source software, we were noticed and got taken up there. I do have friends since who've moved to the US as well, working at Twitter and others. So again, being sponsored on H-1B visas. The outgoing US president, who's probably outgoing at this point, it's still never sure, but made it a little harder to get H-1Bs. But I suspect with a change of governance here, that may get reverted. We had a second question from Jamie. Do we think the concentration of startups in Silicon Valley is a good thing or detracts from other tech hubs? You know, I think there's been a lot of effort to develop other tech hubs now. We now have an office in London, and actually London is not a bad place to start a tech company now. There was nothing going on when I left the UK in 98, I think it was, but now it's substantially better. I think there has been a very, very positive effort to diversify. US VC funds have opened offices in London, in Beijing in China, in the East Coast in New York, in a place they call Silicon Valley in the Midwest. So Hamburg has a bit of a scene going on now as well. Sorry, Berlin has a bit of a scene going on now as well. So people are trying hard to work in other places, but I think it's I think it comes down to the nature of the culture and the work environment here that's let it prosper so well as well. So I don't think it detracts, but I think people are trying actively to do things in other places, and people should. Really good question here from Ross. Can one specialize in terms of career too early? I was hyper specialized very early on. I've actually always been I've been very specialized as a computer programmer, but I've done so many different things from different technologies. I've always been a jack of all trades and a master of almost none. And I've just learned enough about things to go through. So I would say that actually specialization too early is a bad thing. If I look at as a programmer, the technologies that I've worked with, I've done everything from operating systems, compilers, end user consumer applications, mobile applications, databases, GUIs, software for mathematical modeling, tons and tons and tons of different things. I've programmed in probably 12 or 13 different languages. So specialization early isn't a good thing unless you're so passionate about that one thing, you want to become an expert at that. But technology changes all the time, times change. And I think if you're going to go work in other areas and be an entrepreneur, having a lot of technical breadth is a really good thing. Okay.
Neil, there's a couple of boys here.
All right, let's switch over to the boys in person.
Actually, what did you think?
So immediately after you left university, what were some of the greatest challenges which weren't financial?
What was the greater challenge that was financial was the question?
Come around here and look at it.
Not financial, sorry.
Oh, okay. What was the greater challenge that wasn't financial after leaving university? Yeah, well, I mean, it was sort of kind of intertwined because when we were starting a consulting company in the UK, we had to make ends meet somehow. And my friend Mark that I was working with was actually the better programmer. He really was a specialist at the end of the day and had about 5-6 years more experience than I did. So I decided that my mission was to keep Mark fed with work. So I started doing what I'd call business development and trying to find customers and recruit people. I would spend all my time on the phone, reaching out, emailing, searching the fledgling internet back then for companies that could use our services and trying to win business, basically hustling. So for me as an extreme introvert, I think I did a personality type survey where this is extrovert and this is introvert, and I was all the way over here. That was a really hard personal thing for me to cross, basically just getting out of my shell and doing business development.
You said in the intro you were hacker turned business, and why would you call yourself a hacker?
Sorry, it always the questions all come really damn muffled. I don't know why.
Oh, sorry. Why did you call yourself a hacker in the intro slide?
Oh, a hacker. Okay, so terminology back then. A hacker is someone who just hacks code and produces mediocre software at the end of the day. The technical name for people who actually go into systems is a cracker. I was never a cracker, but now hacker has come to mean both things. So I have friends who are actually real hardcore hackers that, you know, made fax machines print out black pages and wasted people's printers in the early days in Denmark, but I wasn't one of them. A hacker is really kind of like a hacker rank or something, which is one of the ways that you measure coders at the end of the day. A hacker is a guy who just produces code and churns it out with often less thought than one should have in terms of the quality of what you're making.
Okay, cool.
All right.
Another couple.
All right.
Thank you. When you firstly did your startup, what's your expectation of how successful you're going to be?
Oh God, it was a roller coaster ride. You know, you always dream of how successful you can be and how well things can go. Having come out of one company that we'd IPO'd and grown to be worth $1 billion or $2 billion, which was just crazy. There was always a dream of doing that, but after going through the fundraising progress, I actually thought, you know, most startups fail at the end of the day. So pragmatically, we said, well, odds are against us for even any form of success here. So let's not let our hopes run away too much. But then the second thing we thought was, well, you know, a number of companies that friends have done okay. They've built a company, they've got to 30 or 40 people, and they've got, you know, and they've ended up selling the thing for sort of $100 million or something, and everyone's made money and everyone's done good. And that, I think, was our hope and expectation. This has gone bigger and far beyond that now, far further than I would have hoped it would have got here. But pragmatically, I would have never probably actually thought that it would have done. So that's why I'm still having to continue to learn and grow. Interestingly, when I started our company, I didn't want to be the CEO of the company. I neglected that detail. We had another CEO on board. It didn't go very well. And so, you know, with a sense of responsibility to everyone here, I've sort of pushed myself to do that job and done a reasonably good job so far.
Thank you.
All right, you're welcome.
The last one in the room for now.
All right.
Hi. So nowadays we have a lot more we talk about the big 5 tech firms now, the Googles, the Facebooks, the Apples. And how do you think the market power and they holding such a big market share, how do you think this would impact the future of possible startups in the
It actually makes it a lot harder. I mean, a lot of companies here now that want to go and get funded, if it turns out that they're going to be in a business that might compete with Amazon, and Amazon is perhaps one of the largest one of them with as many tentacles, it makes it far harder to raise money at the end of the day. So those companies has definitely inhibited the creation and moving forwards of certain types of technologies, in my opinion, because you come to a point where their market force and dominance of a technology is so big in so many adjacent segments that it makes it very, very hard to just do a point solution and move it forward. So I think it has, from that standpoint, impeded the ability of people to build small companies and do simpler things and make them successful. at the same time, they gobble up tons of tech companies as well before they can make it too big. Often, unfortunately, a fate of startups in the UK appears to be they are particularly prone to getting gobbled up by these larger companies. I think it's because the US is the bigger domestic market for tech spend at the end of the day. And in Europe and in the UK, it's harder to grow them further starting in that market. So they're even more likely to get gobbled up. So there's some talks about antitrust suits in the US and breaking up some of these companies, like was done in the past. It's a political statement. I mean, personally, I think that would actually be a really good thing, and I would be on board with it. Some folks may disagree, but it's definitely impeded it for sure.
Thank you.
That's great. Thanks, Neil. There's a few more questions there online.
All right.
In the chat. Yep.
Very cool. So enjoyed my quick run through the history of computing. I hope that wasn't too much of a bore and made it as fast as I could. Were there problems in the industry as presumably systems we're developing today are built upon rather out-of-date technology and computer languages? What solutions are being employed? Yeah, I think the state of the art in technology and languages and platforms is really moving forward. I mean, you know, systems programming now, Rust is the new language that everyone's using to do that. And it's really moved the state of the art forward. I think there's still tons of innovation in hardware, even though you may not see it. But per the previous gentleman who asked the questions, so much of our hardware innovation is being locked up inside Amazon and Google and Microsoft now that other people can't afford to really move hardware forward because cloud computing is the dominant way in which people are deploying and using technology, and that's controlled by a small number of people. But we're still innovating, and there's still some amazing stuff even coming out of Silicon Valley. My friend Andrew Feldman has built a company here called Cerebras, which is one of the most amazing pieces of hardware engineering you'll see. Cerebras. They've built the world's first wafer scale computer. Silicon chips come on wafers that are the size of old LP records or something. They've produced a computer where the chip is the entire wafer. It consumes thousands of amps of concurrent current and is water cooled and literally has the power of tens of thousands of processors on one machine clamped in giant copper plates. So innovation is still taking place at the end of the day. There are new problems in the industry by outdating technology. New things always come along. Old stuff never completely goes away. Visa still runs on mainframes, as do many transaction systems, but innovation is always going to happen. And John, what are my biggest regrets throughout my career? Good heavens. I wish I'd had a time machine to go back and fix all the things that I've messed up. I mean, I've definitely, I would say the biggest regrets in my career would probably be actually in my startup Yellowbrick. The things I've learned through the School of Hard Knocks, how to do fundraising, how to better manage a sales force, the importance of marketing in a business, all of the things that were adjacent areas that I didn't really want to understand. And I think at the end of the day, becoming a CEO, I've got to know enough about every single aspect and vertical of business to be dangerous. And I always thought that I could just focus on the technology, the customers, and the product, and somehow that would carry everything else. And that hasn't been the case. So that's probably my biggest regret. Okay, Brian, watch the video on accelerating ML with Yellowbrick. Good man. Sentiment analysis, filtering records via a SQL query. How is Yellowbrick better than other data warehouses? Is better search algorithms for other queries or something else? So I didn't really want on a school call to go and pitch the technology for my company, but it's primarily about economics of ownership and very, very large data sets. So if you've got data sets ranging from terabytes to petabytes, Yellowbrick is a brute force engine that could crank through trillions of rows of data and gain those insights and filter it far faster and far more cost effectively and far easier than any other vendor can. So there's sort of almost an order of magnitude increase in price performance. It's part of our core IP there. So that's what Yellowbrick does that's special in a nutshell. All right.
Okay. Neil, I just wanted to point out that that question was from one of the boys who's over in Hong Kong, COVID-related reasons. So he's one of my boys in the upper sixth. So.
Oh, brilliant. Okay, super. Hong Kong is my other home. So I love spending a decent amount of time there.
So on the chat, there's another one.
A couple more questions have come in on the chat as well. Has VC culture eaten the world, or is there still room for garage and spare room bootstraps? If it has, is that a good thing? We actually did start Yellowbrick in my friend's garage. yeah, you can still bootstrap companies that way. I don't think there's any reason why you can't build a small business that starts organically and grows. But I think if you do that, you realize that it's probably the odds of making it big are very, very low without outside investment, because as we'd said, the dominance of so many other companies in so many segments and so much tech, the amount of money that it takes to really get to growth now is substantially more than it used to be. I mean, at Yellowbrick, we've raised nearly $200 million to do what we're doing. My previous startup raised 100 million, and that was considered a ton. The other data warehousing startup called Snowflake Computing has raised over $1 billion to do what they're doing. So as technology becomes more dominant, and this is partly fueled by the amount of liquidity in the world and money created by central banks that has to go somewhere to find a return, the barrier and the amount of investment your competitors take dictates you have to keep pace with this and go in the market. Otherwise, you'll just be disadvantaged. So I don't think VC has eaten the world, but if you want to make it big, it's sort of necessary now. A couple more questions here. How do we think technology landscape is changing with many instruments that let people build stuff without really knowing the code? Are there more opportunities for non-technical guys, people who don't code? What should you go learn? I think now, data science, machine learning, business intelligence, without a doubt. I think even if you're not a really strong coder, the ease by which, for example, Python lets you do things like machine learning, data intelligence, BI, getting insights, will let you be a person with really good business acumen and be successful. So many people now have strong careers among the fringes of technology, learning about the business, learning about the data, and using how to apply tools like BI tools, Python, machine learning there, that's definitely the zone to go in right now. There's a massive deficit of data scientists in the world. If you're good at statistics and you have an acumen for business, that is the place to go right now if you don't want to become a hardcore programmer but do really well. Okay, what's the vision for Yellowbrick given the rise of Snowflake over the last few years? It's a very, very competitive industry. In data warehousing, there is tons of legacy technology. The legacy vendors are Oracle, IBM, Teradata, some Microsoft. The new technology, Google, Amazon, Microsoft, Snowflake. So we see ourselves competing with these dominant cloud vendors as well. We're just going to keep growing the business. We've ended up going after the market in a different way than Snowflake. Most of Snowflake's customers are SMEs. We sell to large enterprises. We also cater to customers running their own data warehouses and on-premises rather than purely cloud users. We run in both the cloud and on-premises as well. So we were going after a slightly different sector of the market there.
Great.
All right.
Yeah, that was sparking a lot of interest, of course. What a fascinating talk, Neil. It's just been fantastic. Giving the opportunity of the boys here, they do have wonderful opportunities, and to have you able to be here virtually, we look forward to seeing you in person. And maybe when we get the coronavirus down, we'll be able to see you early in the new year or something, but we'll see how we go. But thank you very much for a wonderful presentation.
Apologies if I talk too fast. Feel free to replay it in slow motion or something. But thank you, Peter. Thank you, Headmaster, as well, and everybody for the opportunity here. It's been great. And my email is neil@yellowbrick.com. If anyone wants to reach out, any boys, careers in tech, any advice that I can give, just feel free to ask, and I'll be happy to help in any way I can. So thank you very much indeed.
Well, thank you to everyone for participating, and that's all for today. Great.
All right. Cheers. Bye-bye. All the best. Stay safe.